Now let's look at this question. Identify products never ordered before by any customer. So I have two tables, ordered items and product. So if you see, the ordered items has three products that were ordered, 1, 2 and 4. Whereas the product number 3 and product number 5 were never ordered. So how will you identify the products that were never ordered by any customer? So the output should look something like this. There are several ways of writing queries to populate this answer. Let me show you few of them. We will be using not in. So very first thing that I will do is, first of all, I will retrieve all the unique product IDs that appear in the order items table. So as you know, order items table contains the list of product IDs that have been ordered. Okay, so for that what I will do is I will just simply do distinct product underscore ID. All right, let's see what I get. I got the distinct product ID from the order items table. Now I will write the outer query wherein I will write select product underscore ID comma product underscore name from products where product underscore ID not in, and then I will enclose this entire thing in a parenthesis. Let me run this solution. And I got the two products that have never been ordered by any customer. So one of the pros of this approach is it is simple and intuitive. It is easy to understand and implement, and it is widely supported, works on all relational databases. It is readable also. One of the drawbacks of this approach is performance issues can be slower on larger datasets, because the not in evaluates all the values in the subquery first and then it goes to the outer query. Okay, and also the null handling. If the subquery contains null, the query will result in no results. Okay, so that part you have to handle in your code. Now let's see another approach of writing the same solution. I will first remove the old solution. I will use left join and is null clause over here. So first of all, I will write select select from products. I'll give it an alias of P, and I will do a left join order underscore items. I will give it an alias of OI on P dot product ID equal to OI dot product ID. All right, where OI dot product underscore ID is null. Let me first show you the output of this query without this where condition. I will comment this line and I will run this query. So this is how it looks like. So wherever the null is populated over here in the product ID, these are the items which were never ordered because it didn't find any matching product ID in the left table. If I comment this part, if I uncomment this part and run this query, it gives me all those records which were never ordered. For the output, let me select the columns that are required in the solution. Okay, so this is the output that is expected. One of the positive side of this approach is that it is efficient. It is optimized for indexing, indexed joins, and handles large data sets better than not in solution that we wrote before. Also, the null handling works seamlessly even if ordered item dot product id contains null. Okay, and the drawback of this approach is complexity, slightly complex, because you have to understand this not in thing. Otherwise, this is one of the good solution that you can write. Now let's look another solution where we will use not exists. First of all, let me write the query. Select product underscore id comma product underscore name from products p where not exists, and here I will write select one from order underscore items. I will once again give it an alias of oi, where oi dot product underscore id equal to p dot product underscore id. All right, let's see the output, and it gave me the same output. So what's happening here is the subquery that you're seeing over here, for each product in the outer query products, this subquery checks if there is at least one matching row in the ordered items table where product id of oi, that is order items, equal to product id of products table. Okay, the purpose is simple. It simply determines if the current product id of the product exists in the order item table or not. And then this not exists is something which is self-explanatory. It simply filters out all those records which do exist, all those product IDs which do exist in the ordered items table. One of the positive point of this approach is it is quite efficient. Also, it does the row by row evaluation. It might be slower than set based approach like left join for smaller data sets. Now let us see another approach of writing the same solution using group by and having clause. Okay, let me remove this solution, and first of all I will mention the columns that we need. P dot product underscore id comma p dot product underscore name from products p. Okay, now I will do a left join with the order items. I will give it an alias of oi on oi dot product id equal to p dot product id, and then I will do a group by these two columns. Group by, I'll just select copy paste having count, and I will use oi dot product id product underscore id equals to 0 solution, and we got the same solution. One of the best part of this approach is it can be easily extended to include other aggregations like total quantities, etc. Okay, works with null values as well. There can be some performance cost because of this aggregation count, which adds an overhead, and it is slightly more complex than previous solutions, but it works good. I hope this was useful. Follow me for more such contents. Thank you.